So we want to do a quick review of titrations and some key terms and key concepts. And so to do that, we're going to first look at this slide. I'm going to ask you to pause and read the slide. And I want to point out that this gives us some key terms that you need to know and be able to apply when it comes to titrations. Let's look at a setup and see if we can apply those terms a little bit more closely. So here is our long glass tube, our burette, that contains our titrant. Remember that the titrant is the solution that we know the molar concentration of. And then in the flask down below is where our unknown sample is. That's called the analyte. And we always add an indicator to our sample down there, so we will actually know when our titration is complete. So we're going to add titrant until it reacts completely with our analyte. Ideally, we would stop at the equivalence point where the moles of, for example, hydrogen ion and hydroxide ion are equal, or in a redox titration, moles of what's being oxidized and what's being reduced are equal. But usually we have to go and drop past before we form the endpoint, and that's where the indicator changes color, and we know that all of our sample has reacted. So one thing you want to be sure to do technique-wise is to make sure you're swirling your mixture as you add your titrant so that it can completely react as it gets added. We're going to use a burette. And so just a reminder, burettes are numbered from top to bottom, 0 to 50 or 100. And so you always want to look at the numbers so you can kind of orient yourself. We're going to always read a burette out to the hundredths place. And we read the initial volume and the final volume, and we subtract those to get our volume of titrant added. Again, the volume will always be to the nearest hundredth of a milliliter. Quite accurate piece of equipment. When you're setting up your burette, a few lab technique ideas, maybe errors that you want to avoid. You always want to put a beaker underneath your burette in case it leaks. You want to rinse it with some distilled water, but more importantly, you want to make sure you coat your burette with some of the titrant. So we pour about, I don't know, maybe 10 milliliters in there, roll the burette around over the sink to make sure it's completely coated and that the molarity that's in the burette is the molarity that we know for our titrant. You fill the burette all the way up above 0, let it run out a little bit to make sure it's full all the way to the tip. And we always record both initial and final volumes. So back in Unit 4, or in your textbook section 4.8, when we worked with titrations, we were given information like the volume or the mass of the analyte, the sample, and we were either asked to read or they told us the initial and final volume of our titrant added, and we were able to do some stoichiometry to determine the molarity of the molar mass of the sample. Well, we're going to delve a little bit deeper now. We're actually going to focus on the chemistry that occurs throughout the titration process, even past the equivalence point and past the endpoint. So we can, so you'll still see problems that are like this one. This one's from chapter 4, and it's just a stoichiometry problem, basically. I'll let you review that, and you can make sure you can see how I did volume times molarity gave me moles. I did my mole ratio step and divided moles by volume to get molarity. You still need to be able to do that, but now we're going to focus on what's happening with the pH. And we'll be generating a titration curve where we're looking at changes in pH. So here we have a titration curve for an acid-base titration. And I've given you 3 questions. And I want you to pause the video for about 30 seconds and think about what you would answer for those 3 questions. Now, looking at our graph, notice that the initial pH is low, less than 7. So that tells us that in the flask where our analyte is, we must have had an acid present. And along the x-axis, we have volume of sodium hydroxide added. That's our titrant. That's what's contained in the burette. And the pH is increasing because as we add base and it neutralizes the acid, there are fewer hydrogen ions that remain, so the pH slowly creeps up. Notice, though, that here on this vertical rise, the difference between maybe this pH and this pH is like maybe 1 or 2 drops max. So that's a very small volume that it causes that big pH change. We've got two important points to look at here. First, we have our equivalence point, and that's where the moles of hydrogen ions equal the moles of hydroxide ions. We're doing an acid-base titration here. Notice that this titration has a pH of 7 at the equivalence point, but that is not true for every acid-base titration. And then our endpoint is here. That's about 1 drop past the equivalence point, an excess bit of titrant's added. There's no more acid for it to react with, so instead it reacts with the indicator and changes the color of the indicator. So our next class, we're going to look at the chemistry that's occurring throughout the titration, and we'll talk a little bit about choosing a proper indicator for a given titration.